Hi, in this video we are going to talk about the Newton method together. So let's get started. I'm going to include the IO stream as usual, and I'm going to include the math.h header file. We are going to use the standard namespace, and I'm going to define the fx method, which will be, for example, the power of x to the 2 minus 2, and this equation is we want to calculate the square root of 2, because x squared minus 2 is equal to 0 is equal to x squared is equal to 2. Then the square root of we just have to square root both sides, and we get that x is equal to square root 2. So we just want to get the square root of 2, and of course we have to define the derivative of this method, which will be, for example, d fx, which will be, if you are familiar with derivatives, 2 times the x. Okay, so we will have a void Newton method, and it's going to get a double reference, and we should calculate, I think we should calculate an error term. So here we just have a const double error is equal to 0.001. So here we just have to run our algorithm as far as the absolute value of fx is greater than the error term. And we just have to use, as we have seen, it's very easy implement this method with the iterative form fx divided by dfx. And that's all. We don't have to return anything because we get a reference. And here we just want to, we have, for example, the guess double x is equal to 4. We have a Newton method with the x, and the root of fx is equal to and I'm going to print out the x and an end line, and I should return 0, for example. So here we should get the square root of 2, which is approximately 1.42, I think, something like this. And yeah, 1.41. If we set the error term to very low, then we get a better solution. Yeah, something like this. And if you want to, just to make sure, for example, we want to get the square root of 9, of course we should get something like 3. And we get precisely 3. So that's all about the Newton formula. As you can see, we can implement it very easily with the help of this iterative formula. We just have to run our algorithm until we are inside the error term, and that's all. The main disadvantage, as we have discussed earlier, that we have to know the derivative of the given function. So that's all. Thanks.